Assalamualaikum and good day. Okay, this video we'll continue with the new subtopic for chapter 1, which is continuity at point. Okay, we are going to look whether the function is continuous at point x equal to c, for example. Okay, so on a plane curve, we have two conditions here. Let's say for this one, we have break. Okay, break, that means it is separate here. Okay, it's not continuous. Okay, and whole is the one like this. Okay, the dotted is whole. There is not no fill inside the bullet, so that's what we call whole. Okay, and then for this one, it does not have any breaks or holes, and thus this is continuous function. But since this one it has holes, okay, here, and also break, that's why it is a discontinuous function. Okay, and next, okay, this is important. So a function f(x) is said to be continuous at point x equal to c if all these following conditions are satisfied. Okay, the first one, it should be fc is defined. Okay, that means there is value at that point. Okay, and the second one is limit f(x) when x approaches c exists, which means limit x approaches c from left, f(x) must equal to limit x approaches c from right, f(x). Okay, and the last one, limit f(x) when x approaches c is equal to fc. Okay, that means here the value of 1 must equal to the value in 2 as such. Okay, if one or more of the conditions of this definition, that means one of these fails to hold, so we conclude that f(x) has a discontinuity as at x equal to c, or f(x) is not continuous at x equal to c. It's the much simpler form. Okay, and please note that polynomial functions, okay, any polynomial functions are continuous everywhere, and any rational function is continuous at every point where the denominator is non-zero. Okay, and had discontinuities at the points where the denominator is 0, because for example, as you can see, y equal to 1 over x. Okay, this is the graph here, x, y, the graph is like this. So here we could say that y equal to 1 over x is not continuous at x equal to 0, because as you can see, when x equal to 0, it will go towards infinity. Okay, let's look at examples. We have 4 examples. The first one is this one. Okay, given this piecewise function, and we need to determine whether f(x) is continuous at x equal to -3. Okay, my advice will be for you to draw the number line. Okay, this one is for the function that is less than -3 because it's on the left, and write the function for x greater than -3 on the right side of -3 here. Okay, and then here, you just need to write the function where we substitute the value of -3 to find the value at that point. How do we know which function that is equal to for f(-3)? Okay, here you need to refer to the piecewise function where the inequalities has equal there. Okay, next, remember, please follow these steps. Okay, it is compulsory to do condition by one. Okay, so the first condition is this one. We need to determine whether the value at x equal to the value of y at x equal to -3 exists or not. Okay, so we calculate for f(-3). Okay, we use the function this one because the inequalities is equal to -3 here. Okay, -3 squared plus 9 divided by 3 times -3, which is equal to -2. Okay, and next, continue to the condition 2. So for condition 2, we need to check whether limit x approaches negative 3 fx exists or not. And therefore, you need to determine the limit for fx when x approaches negative 3 from left and right. For the limit from left, we consider this function. Okay, this function, because this is the function that is on the left of negative 3. And this one is for right. Okay. Pay attention to how I write the limit. Okay. Right now, write the function first. Limit the function x squared plus 9 over 3x when x approaches negative 3 from left. Then only substitute the value and calculate. Never write your function, your limit like this. Limit x equal to negative 3 from left equal to, and substitute the value right away. This one is wrong. And another one that is wrong is like this. Limit x approaches negative 3. Right away, you substitute the value. Let's say like this. Equal to negative 2. This way is also wrong. Please write it correctly. Okay. So next, limit x approaches negative 3 from right. We use the function x plus 6 because this is on the right side of negative 3. So next, substitute the value of a negative 3. We have from left is negative 2 and from right is 3. And limit x approaches negative 3 from left are different. Okay, does not equal. That's why limit fx when x approaches negative 3 does not exist. Please write step by step. That means write this one. It is not the same, therefore does not exist. Okay. And hence, we can conclude that fx is not continuous at x equal to negative 3. Remember to write it step by step, never skip unnecessarily. Okay, let's look at the next example. Given to us this piecewise function, and we need to first find the limit of x when x approaches 0. As I mentioned earlier, it is advisable for you to sketch it in to draw the number line. So we have 2 points here, negative 2 and 1. So here is negative 2 and here is 1. The function less than negative 2 here. As you can see, I wrote it on the left side of negative 2. And the function in between negative 2 and 1 is written in between of them. And the function for x greater than 1 is on the right side of 1. Okay. And the values that I calculate in on the top of the point is actually the value at that function. Okay, for example, this one is f negative 2 and this one is f1. Okay, so the first one, we need to find limit fx when x approaches 0. Where is 0? 0 is here. Okay, 0 is here. So which means here, limit from left and also limit from right will be, we will be using the same function. Okay, that's why you can conclude it directly. Limit 3x squared plus 5x plus 2 when x approaches 0. Substitute the value of 0 and hence we have the answer is 2. Okay, and then the next one, determine limit of x when x approaches negative infinity. Where is negative infinity? Negative infinity can be assumed to be right here. Okay, which means it will involve this function. Okay, sorry for my mistake here. It's okay. I will do it again. Okay, this one is incorrect. Sorry. It would be this one. Limit x approaches negative infinity 4 minus x squared over x plus 2. Okay, we need to use the rule of okay, what is the highest power in the denominator? The highest power is, okay, x. So divide all the terms with x. Like this. And here x over x plus 2 over x, simplify. Okay, let me calculate first. Okay, here we simplify. This one is going to be 1. And here is 1. Okay, like this. It's 1. So next, just substitute the value. We have here negative, it will be 4 over negative infinity minus negative infinity over 1 plus 2 over negative infinity. And these two gonna be 0 because anything divided by infinity is 0. And the final answer would be negative times negative is positive infinity. Positive infinity divided by 1 is positive infinity. Okay, sorry for my mistake here. Okay, please pardon me. Okay, the next one is B. Find the value of k if limit x approaches 1 fx exists. Okay, since limit x approaches 1 exists, it means that limit x approaches 1 from left, write the function first, is equal to limit x approaches 1 from right. Write the function then. Okay, and then only substitute the value of 1. Okay, here after you substitute the value of 1, calculate. Okay, ln 1 is equal to 0. You can check it by using your calculator. And then rearrange everything and solve for k. We have k is equal to 5. Okay, this one is simple. Done. And then next, determine whether fx is continuous at x equal to negative 2. Therefore, the first thing that you need to do is condition 1. Okay, condition 1, f negative 2. Use the function when that is equal at negative 2, which is this one. Okay, 3x squared plus 5x plus 2. Yeah, that's right. Okay, substitute the value of negative 2 and hence we have f negative 2 equal to 4. And then next, the second condition. Determine the limit of x when x approaches negative 2 from left and right, whether the limit is exists or not. Okay, so when we substitute for the limit x approaches negative 2 from left for this function, it's going to be 0 over 0. And it is indeterminate form. And for in this case, you need to factorize to cancel the common factor. 4 minus x squared is 2 minus x times 2 plus x. Okay, cancel out the common factor and then substitute the value of negative 2. 2 minus negative 2 will be equal to 4. Okay, and then next, limit x when approaches 2 from right. We use the function on the right side. Okay, this one is on the right side. Okay, this one should be negative 2. Okay, negative 2. And substitute the value of negative 2 in this function as it is the same one. I just rewrite the value here, this 4. And as you can see, both values are the same, 4 and 4. And this one is compulsory. Okay, therefore, limit fx when x approaches negative 2, is equal to 4. Okay, and then for the third condition here, we need to show that f negative 2 is equal to limit fx when x approaches negative 2. So f negative 2 is 4. Limit fx when x approaches negative 2 is also equal to 4. Okay, 4 is equal to 4 and therefore fx is continuous at x equal to negative 2. Okay, that's it for the second example. I'll continue in the next video. Thank you.